Welcome and happy International Women's Day for those that you celebrate it. It's really great to be here. And wow, what a great audience here. Either you're trying to get out of the heat, which we'll talk about, or you're really interested. So we really appreciate you being here. So we all recognize that the climate is changing. We all see it. Whatever part of the country you're from, whatever part of the world you're from, you see the big changes. You see the temperatures rising to record degrees. You see the weather changing. You see the storms more vicious than they've ever been before. You see the water starting to rain in India at a time when you never expected it to rain. You see the drying savannas across Africa. You see families in Vietnam that are worried that they're now going to have to move up into the mountains, no longer can live on the coast where they make their living because the water's going to rise. It is scary, but it's not inevitable. And what we're going to talk to you today about is what we're doing at the Department of Energy, talking to you how you can help us to make sure it's not inevitable. So I'm Jerry Richmond. I'm currently serving as Undersecretary for the Department of Energy, Undersecretary for Science and Innovation. I'm a chemical physicist by training. I've been working in a lab for about 40 years until I took this position. I'm thrilled to be able to be with you today in this capacity. In this role, I oversee all of the funding that the Department of Energy puts out to the fundamental sciences in about $8 billion portfolio in physics and chemistry and material science and computers and nuclear and fusion, and that's a few of them. It's a great group. I also oversee the $5 billion portfolio that funds all of our programs in renewable energy, in nuclear energy, in fossil energy and carbon management, as well as Arctic energy. This money goes to fund students and faculty in universities all over the world, mostly in this country. And it also goes to support the 17 national laboratories. I oversee 14 of those national laboratories, which are a big deal. They're really the gems of science and innovation in this country. And it's a pleasure to be able to serve in that capacity. So we're here today to talk about all the things that are going on in the Department of Energy, particularly with a particular focus on our aggressive approach to issues of climate change and making sure that we can reach the President's goals of 100% free, carbon-free electricity by 2035 and net zero emissions by 2050. And we're committed to that, and an exciting time to be here. So with that, I will now have Dr. Keller, Martin Keller, here to introduce himself. He's one of the lab directors of one of our amazing laboratories. Martin, it's yours.
Yeah, thank you. Thank you, Dr. Richmond. Let me also go already immediately off script. I want to use being this amazing Women's Day also to thank you. I know Dr. Richmond many, many years, even before what she's doing now, being very active in the community about women or female in science. And I want to say for all of the scientists, thank you for all what you have done during this time, because it's a very important topic, I think, to all of us to further have this inclusiveness and bring everybody into science. Because what you will also talk to you today about, and what Jerry started, we have a planet to save, and this means we need to have the best talent working on these problems to move this forward. So again, I'm Martin. I'm the director at the National Renewable Energy Laboratory, NREL. We are one of the small labs within the Department Department of Energy. So we are focusing on energy efficiency, all the renewable energy technologies, and also on this energy transition. So how can we move this forward? How can we bring the next way of the energy systems and use this from the research to the deployment side? We are part of the 17 U.S. Department of Energy national laboratories. So again, how many hands, who knows the national laboratories? Have you heard about them? Yeah, there's a few of them. So probably all have seen, because we hear a lot of movies also, Oppenheimer. You have seen Oppenheimer probably. As you know, there's Los Alamos is on there. This is where the national labs actually started, one of the first ones in the space, and of course now we're having a broad portfolio from still the kind of deterrence, but a lot of work in the energy sectors across all the different areas and a lot of very cool fundamental science. So that's why, for me, being part of the national lab system is my dream job. I couldn't have a better job. So what we want to talk to you about is what you're also seeing on here is the Earthshots. So we want to walk you through this to see what is this, and hopefully you will take something away from this to see, ooh, this is how I as a scientist or engineer or in this area can participate, or even if you're just interested in the research where we're going as a nation, we thought hopefully that you leaving the room and learn a little bit about this amazing program, what was initiated just a few years ago, and I give it back to you.
That's right. That's right. So in addition, towards the end, I'll talk a little bit about all the tax breaks that are out there for you guys to take advantage of, because there's a lot of money out there that the Department of Energy is managing to make sure that your homes are as efficient as they can possibly be and as insulated. So, okay. The Energy Earthshots. This is an initiative launched in 2021, and it really is geared towards an unprecedented approach to decarbonization and energy efficiency, clean energy production by 2035 for the nation. So these are Earthshots have a 10-year span, and that is really to go after the hardest areas that we now have in our society to get to make clean energy from a technical and scientific point of view, and also decarbonization. And so based on what we've done to choose these 8, which we'll talk about, is we've done our laboratories, our scientists at our universities have gotten together to identify what are the areas that we really, if we don't get these figured out in 10 years, then we're going to be left behind. And so the analysis that we've done is that to figure out, first of all, in this particular topics for any Earthshot, they have a goal. And the goal is to get the technology to commercialization, right? So that means get it out of the lab and get it applied, get it demonstrated, so then a company will take it up, okay? So that means, for example, that we've got to get the technology developed enough that the cost can come way down, that the risks can come way down, so a company will take it on, make jobs, keep it here in the United States. And so that's really a big goal of these Earthshots. So that means that we have to have our scientists working not only the discovery science, but they need to be quickly passing it on to those that are putting it in the applied areas, and then passing it even further to be able to go into the marketplace. Okay, so with these, we have some real technical challenges, and so we'll highlight a little bit of those. But it's more important I hope that you can gather from this what we see are key areas that this country needs to invest in order to go forward. Okay, so that's what these 8 are. So and the whole point is, if we get to the goal after 10 years, in 10 years, it'll make it easier to pass this on then to our Bill and IRA money, which has come in with these recent bills. So, Martin, what do you think?
Let me also add perhaps a little bit, because, you know, for many of you perhaps in the science fields, or even if you know somebody, a lot of times we separate, you know, there's this fundamental science, and then there's things which what we call applied science. And this, what I think is so amazing on this Earthshots is that we're trying to combine that you look at the fundamental science and see this through all the way to the applied science. We are living in a very interesting time. So, you know, when you look at the outlook about climate and all this, you could get very frustrated and say, oh my God, well, this all go down in a bad way. But there's also a lot of very positive outlooks. And the key is right now that we're in a stage where we have a lot of technology ready to be deployed and ready to be brought into our economy. But then in each of this technology, and this we will see when you go through the Earthshots, are points where we need to do more innovation to make it cheaper, to make it more integrated, to bring it to the next level. And this is what's, in my view, so unique on this Earthshot, that you go and say, okay, we want, and you will see this, we want to have, let's say, hydrogen at a certain price. To achieve this, we need fundamental science, but we also then need to work with industry in team to get this technology de-risked and deployed to the next level. because we always say we don't have time just to wait and do this how we've done this historically. NREL, our labs, you might know us from, you look at Mars rover, so the solar panels on the Mars rover, this is technology originally coming out of NREL. It took 30 years, what we were saying from some hippies who thought, oh, solar one day will change the world, to now being one of the cheapest ways of producing electricity. 30 years. We do not have 30 years. We only have about 10 years to advance the technology and get it then deployed. This is why we need to think differently, and that's why the Earthshots is so exciting, to link between science, the fundamental side, and the applied side, and the work with industry to get it into the market. So that's why you see on these topics why me as a scientist, I'm super excited where we're going with this area.
Yes, so we might start levitating because we get so excited about this. But so the first one, long duration storage. That one is that's the long duration storage shot, and it has a goal of targeting 90% reduction for long duration storage. We're talking about storage for 10 hours or more. Big goal, and we need to get there in a decade, and we're not there yet. And we don't just mean your little batteries or even the ones that are in your computer. We really mean all kinds of storage. So we're agnostic with regards to what kind of storage that would be. But we know that we need to be able to get renewables to the grid, and then there's got to be some way to be able to store it and take it back off, because as you know, wind isn't always blowing and the sun isn't always shining, and so we need to have ways that we can store it. But you also know when you're buying your EV, your car, that you want to have some kind of a place some kind of a battery system maybe around your home, that you'll be able to run your house when the electricity goes down, but also you can power up your car again. So this is a big goal with this storage, to get it down again 90% cost reduction than where it is right now. And to make that go is a real challenge, because there's a lot of, Martin and I are a team here. I've mostly spent my life doing research in very fundamental science, very basic science. And Martin's on the other side of the room on this. But the point is that, so I'm going to talk a little bit about sort of the fundamental stuff that has to be figured out. And then Martin can talk more about, where he sees that is. So for example, with batteries. With batteries, we've got lithium-ion batteries. The lithium is a real challenge right now with regards to having enough lithium for all the things that we want to do, and they often go in your batteries. So some of the things that our laboratories are working on is to see if you have a replacement for lithium. Can you use table salt? Can you use sodium instead? And so some of the research that's done in these laboratories and that we fund is in that area. If any of you know anything about electrochemistry or battery, you know there's a cathode and an anode. You got to figure out what are the better materials that are cheaper, more efficient, in order to get that cost down, that 90%. So there's a whole, and if you think about, energy can stored a lot of different ways. So, we have a dam. We have a dam that holds the water up. That's holding the energy up, because then when it comes down, that's when we collect the energy, right? So there's different, and you can do the same thing in a number of different areas that we'll talk about. But the point is, we've got to get the fundamental science figured out fast so we can pass it on to Martin.
So who's here from Texas? Anybody from, yeah, okay. So look, we had an amazing experiment going on in your state not so long ago, last summer, when there was the big heat wave hitting Texas. It was one of the examples. So Texas is an interesting state, because you saw huge deployment on renewables, wind, and also solar. So now what's happening in this space, when, by the way, the problem there also during the heat waves, what you all had an issue in Texas is during heat waves, the thermal plants, so our gas plants, are going down in efficiency because it's getting so hot that their efficiency goes down. So what most people might not know, but here in Texas, the grid was saved by especially the wind and also solar on the grid. But now there's a problem. In Texas, sun goes down, and then the wind picks up, and there's a window. And this window can be, if it's 2 hours, it's okay. If it's 4 hours, it's getting to a point where how to bridge this valley. This is why storage on the grid will be so important. So, but then there might be time when we deploy more of this renewable that suddenly, well, you need to have half a day where you have no wind or no sun. And this is why the combination of the deployment of these renewables in combination with storage will be so critical to further accelerate the deployment of clean energy into our grid system.
Okay, that's number one. Number two, it's the heat beneath your feet. So in this case, this is geothermal. And what we're working on in the Department of Energy is not just geothermal like you might have at Yosemite or Hot Springs. Okay. Now you really can hear me. Okay. So not like you have at Yosemite or some hot springs. I'm actually from Oregon, and I've hung out at a few places that have hot springs there, and especially a little Brighton-Bush, they call it. In that case, they have the heat that goes through 10 cabins, and if you're on cabin number 10, you freeze. But the point is they're still using the heat to do that. We mean deep heat. We mean deep heat, thousands of feet down, because that's where the heat is, the real heat that we can use. And the idea is to be able to then take water, send it down and to heat it to that temperature, get the heat up here, and then be able to come up and then run a generator, right? Then run a turbine that'll give you the electricity, okay? We could heat 65 million homes if we were able to develop that to the level that we can in this country. So there's just huge advantages to get it down to $45 per megawatt hour. And we could deliver heating and cooling all over the country with this. So this is a particularly important Earthshot for us because of the fact that there's so much more that we can do with this. But what are the challenges? Well, you got to go that deep. Well, we certainly know that we have industries that go that pretty close to that deep, not quite that deep, but they know how to drill deep. But then, whatever you put down there, it can't melt, right? Right? So you've got to have the materials that are robust enough. First of all, you've got to have the drills to be able to get that down that far. But then you've got to have the materials that are robust enough to make it happen and carry it back up again. So it's a real material science challenge to be able to get all of that to work from a very fundamental science point of view. And that's what we're working on. And so now over to Martin.
And look at, so I'm off now too.
Here you go, man.
Okay. So, and that's another example where what happened over the years, the linkage between the really cool technology coming out of oil and gas, and now the deeper understanding on the so-called subsurface. And that's again where within Department of Energy, where we have the world's fastest and largest computers, where we can now model and simulate the subsurface at a level which we could not do even 5 or 6 years ago. So now, linking oil and gas with the new drilling technologies, when a deep understanding of the subsurface will enable this geothermal energy to come to this point, you know, what Dr. Richmond said, that this is now a very amazing potential to have this here in our country. You might know, I've ever been in Iceland. Whole Iceland is powered by geothermal. Well, that's easy for them because it's just bubbling there on the tectonic plate. It's just bubbling up to them, and all the hot pools. But we also can do this and then combine this technology with other renewable technologies, such as concentrated solar or even regular solar power, to really bring in what I say another way of very long-term storage, which is the heat in our subsurface. And combining these two will enable us tremendous new long-term opportunities. And this is also where a lot of new companies come in and looking at the drilling technology from oil and gas and then adopting this for geothermals. So I always say this is a super example. 5, 6 years ago, if you looked around and people said, geothermal is, we at the maximum, it's dead. And now this, the innovation coming out of science, there's this absolute new renaissance coming in geothermal, and we feel that this will be a very important energy source for us here in the United States.
And all those geoscientists that are looking for jobs. Yeah, geoscientists that are looking for jobs. This is a way that you could use that training in order to help save the planet. So a lot of neat things having to do with enhanced geothermal. Number 3 is industrial heat shot. Okay, so when you think about it, there's, and you think about making steel, for example, a lot of materials, it takes a lot of heat. You've seen the pictures of blast furnaces with a tremendous amount of heat that's really generated by different carbon fuels, shall we say. And we'd like to be able to get out of that, get further away from that business, and to where we can get now an 85% reduction in greenhouse gas emissions. That's our goal. 85% reduction in greenhouse gas emissions from industrial heating technologies by 2035. Big goal. We think we can do it. So here's some statistics. Industrial heat accounts for about 9% of the US GHG emissions. That's 9%. Achieving the goal of industrial heat shop would put the American industrial sector on a course to reduce its carbon equivalent emissions by 575 million metric tons by 2050. That's a big deal. An amount roughly equivalent to the emissions generated by all passenger cars on the road in only 1 year, in 2020. Could make a huge difference. And so recently, again, a lot of things that have to be figured out with this, but in particular to figure out what kind of a fuel you can use that's carbon neutral that allow you to get these hot temperatures. So just recently, I had the opportunity to go to Indiana and to go to Cleveland Cliffs. And Cleveland Cliffs is a steel-making factory, one of the biggest ones in the country. And I got to see what they have, and actually in the world, and they have decided they're committed to this. They're committed to be able to use hydrogen to do this, and we're going to get to hydrogen in a little while. But the point is that they've taken it on themselves to put together a demonstration plant that will allow them now to make steel eventually with hydrogen. And it was so exciting to be there to see they're using AI to figure this out also, but just to see how excited this company is, and especially the owner, about the fact that they're taking this on, and they're taking this on all by themselves. Martin.
Well, this opens now to one of my, like, I'm a little bit biased, one of my two favorite Earthshots, and one is, as you mentioned, Dr. Richman, is hydrogen. So you probably all know about hydrogen. I mean, it's an interesting molecule. A lot of people are afraid of hydrogen because, well, you don't smell it, you don't see it, but it's an amazing molecule because, when you burn it, you just create water. And so it's very, very clean. So now the question is, how do you make it? Right now, we also here, Texas is the leader in hydrogen production, but it's all coming right now out of natural gas. So this will create CO2 as a waste gas. So the idea is, can you create hydrogen? This can be now making out of renewables. It can be done out of nuclear. It can be done with other thermal processes. But the idea is to make it in a clean way. So the hydrogen shot, the Earthshot, is to make 1 kilogram of hydrogen for $1. So this is not, it sounds all good, and this in 10 years, so 111. But the key is why $1? Because if you come to this low price, then it's getting very competitive to other energy sources, and even down to this point where natural gas is. So why hydrogen? Hydrogen is what we call a platform molecule. So it's a few years ago, 5, 6 years even perhaps more, people thought that hydrogen only can be used for transportation. So some of might have seen hydrogen cars. Japan was the leader in making hydrogen cars, also some of our US companies. So right now we're seeing a transition in transportation more to electric cars, but hydrogen still plays a very important role for heavy-duty trucks, but also as a platform, because what she said about if you make steel in a clean way, you need hydrogen to do this. Or if you make, some of you might have heard, synthetic fuels, you will need hydrogen to do this. Even if you go and you say you want to make ammonia for fertilizers, if you want to do it in a clean way, you need hydrogen. This is why hydrogen is such an important molecule. And by the way, it also can fall back into this to be a long-term storage molecule, because we can burn hydrogen in the turbine very similar like we burn natural gas right now. So this is why hydrogen is a very, very exciting molecule. So there's still a lot of research to do to get to this $1, and also on public perception, because some people still are worried about hydrogen. Oh, I can see it, I can smell it, what about if it explodes? We all go back, to worry about the pictures of Hindenburg exploding. This is still in everybody's mind. And so we need to show not only the research, but also show the people, yes, it is safe to be used in our daily lives. And this is why this Earthshot is so exciting, because it will accelerate not only on the electricity side, but also on a lot of the chemical side, all the way to materials like steel, fertilizers, and other synthetic and e-fuels. So that's why this is a super exciting Earthshot for me.
Yes, and it's really interesting because we project if we can get at least a 5-fold increase in clean energy and clean hydrogen use in a decade. If we can get there, boy, that would be a huge accomplishment, and we think we can. This particular plant, Cleveland Cliffs, knows that we're not quite there in our ability to produce this much hydrogen. So what they're doing is starting out with natural gas, getting it all set up so that the minute hydrogen is ready to go, they can plug that in. All right, so what's another favorite of yours?
Next one is offshore wind. So there, look, that's also a very exciting story. You probably all know what we're doing in onshore, so wind on our country, in our land. So why offshore? Why do you want to go offshore? So a couple of reasons. Because out there, the wind blows at a more kind of constant way. And if you figure some things out, you can make even larger turbines. So why can we, a little factoid perhaps for you all, so why can't we just build bigger turbines on land right now? The big issue is transportation. So you make our wind blades in a manufacturing place, and they're getting now so large that you cannot put them onto a highway because it doesn't fit through a tunnel anymore. Or there's a curve in the highway and you cannot make the curve. So say, okay, that's what we've done. We put them on a railroad and on a rail. But even right now, the long curves in railroads are so wide that a blade cannot make it anymore. So what can we do now? Well, we can manufacturing the way of making the blades directly on site. We're doing this. But then also, well, let's increase offshore wind. Europe, you might have seen big offshore wind blades in Europe. So the beauty is the ocean doesn't have curves. So you just put them on the barge and barge them out. Works perfectly in northern Germany or Great Britain because I would say their ocean, it's not an ocean, but it's a lake. It's not deep. It's very shallow. So you can use current technology and just make a longer tower. This does not work here in the United States because our line falls off very, very quickly. So we need to have brand new technologies. So it means floating offshore. You cannot anchor them directly onto the ground. So you need to have them floating, or you make counterbalances, or well, we'll see. But there's a lot of research going on into this one. But just give you the dimensions. The world's largest offshore wind machine is right now in China, and I just wrote down the facts. So the diameter of this is 853 feet, so about 260 meters, so almost 3 football lengths. So this one turbine produces 16 megawatt of electricity, so you can power 36,000 homes with this one machine. They, of course, they're cheating because, they put this into a sea which is very shallow, so they use current technology. But how can we bring this technology onto our shorelines, put them far enough out there that we don't worry about looking at them, but then really have them in a way to harness the amazing wind power we have on our shorelines far out there and bring this back. How do we bring it back to shore? How do we make this if it's all floating? How to bring new materials which are resistant to the harsh environment in the ocean? So a lot of research, but tremendous potential for us here in the United States.
So if you don't mind, I'm going to brag a little about your lab. So recently I was at NREL, and as a chemist myself, I'm always worried about whether the materials that we make, whether they can be recyclable. And what they're working on at NREL is blades that can be actually recycled, because the way they are now, the blades just aren't easy to break down. So it was really exciting for me to see all the science that was going in to be able to make renewable that can degrade with time or under the right conditions, these turbines. So it is a really important area.
So now we're getting into another one which is absolutely critical. And when you look into literature, you've heard about this, that no matter what we do, it might not be even enough to go carbon neutral with most of our technology. We have to somehow even take more of the CO2 out of our atmosphere. So then the question is, what are you doing with the CO2? And this is again where the carbon negative shot comes in. So this is that and now we're talking about very large amounts of CO2. So we need to find a way to store this CO2 in our undergrounds. So how do we develop this method for removing carbon dioxide from our atmosphere and then make this that it's not breaking the bank? Because we know how to do this right now, but it's much too expensive. So we need to decrease the cost. So this is one of these technology which will be absolutely critical in developing this. Sometimes now, playing the devil's advocate there, some people say, well, we just can do everything and we just take the CO2 out of the atmosphere, we continue to burn our natural gas and then just pull it back out. No, that's not what it should be. So we need to do this in addition to decarbonize a lot of our technologies. We only will save this planet if we continue to decarbonize our economy and find ways down the road to take it out, because there's certain processes which will be very hard to decarbonize. For example, we're sitting in a concrete building, so to make concrete by nature creates CO2, it will be very hard to decarbonize. And there are many other processes like our agricultural, having cattle around creates methane and CO2. So we need to work on all of this technology. So now we're talking about to take gigatons of CO2 out of the atmosphere and find a way to store this for the very long time in our subsurface, full circle back. That's what we talked earlier about modeling this, to make sure that this is stored away, but we need to do both of these very large innovations to drive this forward.
Yeah, and I was in Louisiana, LSU, just last week or the week before, and just saw what they were doing in working with one of the oil companies, and using all the equipment that they could get from the oil that they got from the oil company to be able to see how they could then store the carbon dioxide that they had as a test facility to get it really deep in one of the equivalent of a wells that was way down there. The fundamental science behind this is not easy, because if you can't just suck air into your tunnel, you have to separate the carbon dioxide from the nitrogen and the oxygen too. So doing that kind of separation requires some really clever we need new ways to even make that more efficient to be able to do that. And remember, and for this particular shot, for the carbon negative shot, it's not just collecting carbon dioxide that comes out of the fumes flame next to a steel plant. It's ambient air. It's taking the carbon dioxide, which is much more difficult to do, and separate it that's just in our ambient air. We got to do it. We got to do it. And there's a lot of, for many of these shots, as the government now has been, with the Biden administration, has been able to work with Congress in order to get the bill and the IRA bills passed, that the companies now are stepping up and they're saying this country is committed to it. So there, for example, in the battery area, when those two bills passed, before the Department of Energy, we have, $100 billion to spend on this? At least, more than that. Anyway, that's more than I can think of. But the point is that once it was announced, before we had spent a single penny, 100 new battery companies started up in the United States. So what we see is not only that the money is there, but people realize there's a future in this country, and that's why I think in many of these areas we will continue to lead in there. Yeah.
So I think we have two more. So it's called Clean Fuels and Product Chart. So what do we mean with this? So even if we decarbonize the way we're taking our electricity, there is still a lot of things which will be right now out of oil and gas, which we also need to decarbonize. So for example, we are sitting in a carpet which is made out of oil. A lot of our clothes has a lot of oil. The chairs, the carpet there, the plastics, name it. So how do you create these materials? And we can come back to the fuel side. How can you make this without creating CO2? So we want to decarbonize the fuel. So most of you probably came on an airplane here if you're not from Texas. So what about if we find ways to create these synthetic fuels, to make these fuels which are not derived from crude oil? So can we make them synthetically? Yes, we know how to do this right now, but the problem is still too expensive. So we have to decrease the cost. So we can, again, hydrogen, when we talked about this, we can then take this hydrogen and CO2 and create the synthetic fuels. Here in the US, we are very lucky that we have a lot of biomass. So Oak Ridge National Laboratory did a study that we've about 1 billion tons of biomass, which we can use to take the biomass, which is a long carbon molecule. It's very branched and complicated, but we are working on technologies to take this and move them over to go into fuels, and then also very important into materials.
Because on the long run, now I'm talking many years out, we need to find a way that we uncouple and not using our oil and gas, which is in our Earth, to do some of these things and emitting this. We need to find a way to create this. So for airplanes, the best example, the easiest technology is to decarbonize the fuel going in. I know some people working on electric planes or hydrogen planes. I'm feeling very comfortable when I fly home this evening in a turbine, jet turbine. I just wish there would be different fuel in there that I don't contribute to the carbon emission. That's what this shot does, so on the material side and also on the fuel side.
Well, I'm excited about this one too, because again, being a chemist, you have a real sense of what things are renewable and what things are not renewable, and we just got to do better at that. But I've saved the best for last, and this is really my favorite one, even though you're never supposed to have a favorite child, especially if you have 8 kids. But this one really is my favorite, and that is the affordable home energy shot. That's to make our houses tighter, make our houses so that the heating bills are lower. So it's all about making the home front more affordable. The shot targets a 50% reduction in the upfront cost of home energy upgrades in affordable housing, as well as a 20% reduction in the residents' home energy bills within a decade. That hits all of us. But it particularly is important for our underserved communities. Let me just stop for a minute. By Justice 40, in the Department of Energy, these billions of dollars that we're putting out, 40% of that must go to underserved communities, the communities that have been left behind for far too long. I've been to Alaska to see the tribes that have been left behind way too long. I've been on reservations where there's no electricity or no running water. We can't afford to do this anymore. And that's why it's great to see that there's funds available now to help, for example, the homes in Alaska, which are falling down into the permafrost, to be able to continue to live as the climate changes. So this home energy shot is really important. Nearly 1 in 4 households nationwide experience high energy burdens, and as a result, more than 20% have fallen behind on their energy bills in 2022. And again, this disproportionately hits low-income families. So what this shot does, it directs the Department of Energy's research and development resources to the households the greatest it can. We now know that in America, 50 million single-home, multifamily, and manufactured homes are rented or owned by households earning less than 80% of the local median income. There's so much that we need to do with regards, and this is insulation, this is windows, this is tighter frames, this is new way of doing things so that we can make sure that the energy costs are down. So last week, I was in Seattle, and they are funded, there's a nonprofit there that's funded to work with low-income apartment complexes to put in heat pumps to heat the water. And in this particular unit that they were working on, it's a unit that has 100 units in it. It's all low income and disadvantaged communities. And they have put this heat pump in, and they are saving the electric bills of their residents by 40%. 40% with just this heat pump. So just really amazing. So, and also, in other parts of the country that I've gone to, you talk to the residents there, and it's saved their lives because of the energy that it's saving them. So we're really, truly committed to this. But again, it takes a lot of work in developing the kind of insulation materials that we need to get to. But on the same time, with the Bill and IRA money, it allows us to extend that work into the deployment area.
So I want to touch also on what you a little bit, give you an example. We have a facility in Alaska, in Fairbanks, and they're specializing on housing for cold climates, and also especially a lot of work with the local and tribal communities in Alaska. And I give you this example when I'm visiting, similar to what you have seen, when you go to some of these villages, the homes were built originally by contractors coming from the lower states. They didn't know what it means to build a home for this very harsh environment. And then they're also not designed for the community. So we started this program with the local community to understand what does the community really need. And this is, again, my example there, why this energy transition, we cannot leave anybody behind. So I'll give you this concrete example of what we've done there in this community. We realized that a lot of this community in this tribal area having about 3 generations living under one roof. So they need to have a home designed in a very different way. They're also based on their history and traditions. They design their homes that the entrance is in a certain way because they know where the winds are coming. They have this tradition that, you know, you take your shoes off, you have a different room there, and then you're going to different areas. So it's a very different design. So right now, a lot of the homes cannot provide a home for the community and the families together. This means a lot of the elder people that cannot live in these homes, they need to move to the next city, which is in Alaska, hundreds of miles away sometimes. It disrupts the whole knowledge flow of these communities. So we had these meetings with the communities and worked with them to see how would you design a home? What do you need? How is the layout? And then we realized that what is the most complicated thing in a house, in a home? There's 2 things. It's the kitchen and it's the bathroom, because this is where the electricity and the installation is. So the idea came up, what about if we design the kitchen and the bathroom in a container manufactured in a manufacturing place, and then you barge it to the villages, and then you teach the people in the villages to build their homes around it, based on with the knowledge we have on insulation and what is the materials you use. This is an amazing, successful program, which is now spreading through many different villages in Alaska. And this shows you the strengths of combining the science with the community work inside the communities and listen to the people who are actually living in these communities. And why we're doing this in Alaska is because we want to learn how we can bring some of this knowledge also to our communities here down in the lower states. And that's, for example, what we're doing with LA, where we're working on this energy transition for LA. It's not enough to do the energy transition for Beverly Hills. We need to do this across everybody, and especially also, for example, South LA. How do you bring these people along? And that's why also these Earthshots are so exciting, and how you link this, that we have mechanism there to reach the communities, pick them up where they are, and help them to bring them along in this energy transition, that at the end, everybody will benefit from a cleaner future for our country.
You know, along these lines, when you think about it, there are many other countries that noticed the effect of climate change well before us. Certainly in areas of Africa that I've been to, they saw the savannas dry up long ago. Some of the difference is that in this country, we could ignore it because we could buy our way out of it. Not everybody. But now's the time where it's become financially, economically more difficult for a lot of people to live through this, and then we finally notice it. It's time that we make sure that we can accomplish what we need to accomplish.
So let me also, because this is a very, very rough topic, honestly, because, you know, we all look, and I would assume when I also look at your faces that you all look very serious right now, because it is a very serious topic. But I tell you, I'm a scientist, probably my family always calls me the ultimate optimist. I'm very optimistic right now because through my job, I'm traveling a lot. I'm seeing many different countries and activities around the world in this energy transition. And I think that we are reaching, as a society, we are reaching this level that we really can do this. If we put our heads together, we can do this. The key is now, and that's again always like when I'm sitting with folks like yourself to give homework to everybody, the homework to you all is to help in this transition. Sometimes I'm hearing this even from our neighbors. Well, you know, what can I do? Well, we all can do small parts to help this transition. I give you this one concrete example, and this comes back to one of the shots here. So how many of you have a home without a kitchen? Yeah, I know. Look, I mean, I ask this question a lot of times. I only had one time a person say, I don't have a kitchen because I never cook. I always eating out. I built a house, I didn't put a kitchen in there. This is, whoa, that's interesting. So we all have kitchens. Why do we not all have solar panels? We can think in a different way in the future. We can really advance this. We can move this forward. It's on all of us. that you sit down with your families and say, okay, what can I do, a tiny little thing to really help in even perhaps talking to our neighbor. Make sure that sometimes I wish we could take politics out of this transition because it's the right thing to do, and especially for rural America, a lot of times is a better future because it will be cheaper and it's give them more energy, resilience, and security. So we can do this, but it's on all of us to accelerate this and be part, whatever we can do in all the tiny situations, to be part of this transition. So that's my homework to you all. Think what you can do to help all of us and the globe to move this forward.
Okay, so now I'm going to pretend like I'm that midnight jiu-jitsu knife salesman, tell you sort of the tax credits you can get right now. So, excuse me, this isn't normally my day job. 30% tax credit on solar panels. You can get 30% tax credits on putting up solar panels. Battery storage systems, 30% tax credit on that. So that you can take your EV and plug it, which you can also get a discount on, and you can plug it right into your house. 30% off the cost of heat pumps via tax credit, and that includes water heat pumps. You can get a tax credit of 30%. I don't know why 30% tends to be the big number, but it is. For home energy audit, you want to have somebody come in and tell you how good or bad your house is. Well, they'll tell you what, you can get a tax credit for that, but then your insulation, again, a 30% tax credit if you replace your insulation. And that can reduce the energy costs in your house by 20 to 25%. The IRA is providing companies $5 billion worth of investments for automotive manufacturing facilities, $3 billion for your U.S. Postal Service trucks to upgrade them, $3 billion for zero-emission equipment for ports, $1 billion for clean heavy-duty vehicles such as buses, and all of this is out there right now. So not everybody can take advantage of this, but at least you might be able to tell somebody else to take advantage of it. But that's really, that goes beyond the Earthshots, because that's what the Earthshots passes on further to the deployment. And that money is in the deployment area of the Department of Energy. So I think that's kind of a wrap for us, Martin.
So I think we have 10 minutes if somebody has some questions. Or
yeah.